Okay, in the previous video we looked at network flows, and I did mention that network flow networks will always have one sink and one source. Well, that's not strictly true. Let's just consider perhaps a network that's got multiple sources. I'm just going to call it S1, S2 and S3. And then it goes off into the network. What we do in such a situation is we force there to be one source, and we call that source a super source. And the super source doesn't represent anything physical to the problem that this network is modeling, but it does allow us to carry on with network flows in exactly the same way as we would have done in the previous video with a network with one source. So let's say we've got this situation here, perhaps, where we've got three sources and we've got different weights on them. So let's say 10, 20, 15, 15 and 20. And we introduce this super source, which I've called S. So the individual sources are S1, S2 and S3, and my super source is just S. And what I'm going to do is I'm going to join up each of these sources to my super source, and then the number on the arc that I'm going to put here from the super source to source 1 is going to be equal to the sum of all the arcs coming out of source 1. So in this case it's going to be the number 10, because if this pipe is saturated, then you're not going to get any more flow out of source 1, so therefore you don't have any more flow into source 1. So 10 is the maximum you need. Source 2, we've got a 20 out and a 15 out, so therefore the pipe capacity is 35 going in, and then the same thing here, we've got 15 and 20, so that is also 35. And once you've introduced this super source along with the appropriate weightings, then you can carry on using the method from last video to go on and solve the problem. The same is true at the other end if you have multiple sinks. So let's say you've got sink 1 and sink 2, and you've got lots of inputs coming in. Off of those, then you introduce a new sink, which is called a super sink, and that has an arrow going into it like that, and then the number that goes onto it is going to be the sum of all of these, whatever numbers they are. So that's going to equal x1 plus x2 plus x3, and then the number on this one is going to equal the sum of all the ones going into that sink. So that's going to equal y1 plus y2. So it's the same thing as the super source, it's just at the other end of the network. And that allows us to have a network flow problem which contains one source and one sink. Okay, so let's have a look at a question. The following network contains two source nodes and one sink node. By introducing a super source, find the maximum flow through the network. So in this situation, we are not told which are the source nodes and which is the sink node. We do know there are two source nodes and there's one sink node, but we don't know which ones. So the way to check is to find all of the nodes which only have arcs leaving it. That is what a source node is. So for example, node A, that has only got arcs leaving it, therefore this is a source node. So I'm just going to ring that with a red because I need to attach a super source to that. B is not a source because it's got an arc coming into it. It's also not a sink because it's got an arc coming out of it. And I can repeat that process for all of the nodes. So this one here has got arcs coming in and going out, so therefore that's not a source or a sink. This has got 4 arcs coming out, so therefore this is the other source. Okay, there's node D down there. This node has only got arcs coming in, so therefore that is the sink. And we can check that the other two. This one's got arcs in and out, and this one's got an arc in and an arc out. So therefore that must be the sink node. Ring that in green, just so we can see where our network sinks. Okay, so introducing our super source then. So it's going to be a big S, and then I'm going to have an arc going into node A and an arc going into node D. The weighting of the arc is going to be equal to the sum of the weighting coming out of that node. So for example, in node A, we've got 30 coming out, so therefore the weighting on the arc going in will be 30. And then at node D, we've got 100 coming out. So the weighting on the arc going in will be 100. We've already got one sync node, so we don't need a super sync. Okay, and now we are ready to go with our method that we looked at in our last video. So let's put in 20 units of flow straight from source to sink. So go through D. So I'm just going to, again, just jot down the order in which I'm choosing my routes. So S, D, E, and I can push 20 through there. So that's going to saturate that pipe. And that's going to push that up to 20. I can push another 20 this way and going around to past G. So that's going to be S, D, F, G, E. That's another 20 going through there. So that's now going to go up to 40. That's going to go up to 20, which saturates that pipe. That's going to go up to 20, and that's going to go up to 20. I can't push any more fluid through F because the pipe, all the pipes coming into F are saturated. Therefore, I know the flow from F to E will be 0. Okay, I can push 20 going up to C and then in. So let's have S, D, C, E. That's going to be another 20. So that's now going to go up to 60. Oops, sorry, I shouldn't have crossed that off because that's a pipe capacity. That's 20 there, and that's now 20 in that pipe. I can push 40 that way and in. So that is route S, D, B, C, E, and that's going to have 40 there. So that's going to push that up to 100, which means that pipe is now saturated, which means all of the pipes leaving node D are saturated. That's now got 40 flow through it, and that's now gone up to 60. There is still more flow I can add though, because I can now look at A. I can bring in 20 flow going through C, and then I can bring in an additional 10 flow going through B. So those two routes are S, A, C, E, and I can put 20 through that, and then I can bypass this saturated pipe by going via B instead. So that is the route S, A, B, C, E. And that is a further 10 because that's got a capacity of 10, which means that goes up to 30 and that's saturated as well. Both sources are now completely full. That's not going up to 50. That's going to go up to 90. So I can't add any more flow coming out of the source. Therefore, I cannot add any more flow to this network. That is the maximum flow I can push through this network. And the sum of it is 20, 40, 60, 130. So that is 130 units of flow through this network. Okay, so we can see how that is exactly the same as the previous page. And just to show you a super sync, I've not got any arcs on this one, but again, you need to identify how many sources and how many sinks there are. In this case, we've only got one source. Every other node has got arcs coming into it, so therefore there's no other sources. So we don't need a super source, but there are two sinks. Can you spot them? If you said E and H, you'd be correct. So E is a sink because that only has arcs coming into it, and H is also a sink because that also has arcs going into it. Every other node in that network has arcs coming out of it, so therefore it is not a sink. So my super sink, which is going to be a node with the letter T in it, is going to have an arrow coming that way and an arrow coming that way. Okay. The number that would go on that arc would be the sum of those three, and the number that go on this arc would be the sum of those two. Okay. That's super sources and super sinks. That's really all there is to know for that. The next video we're going to look at cuts and the max flow min cut theorem. Thanks very much for watching.